Okay, so in this lecture we're going to go over Chapter 2 from the book. We'll be covering the player inputs. We'll finally take a look at the input system. We'll review how the first-person character is controlled, and then we're going to modify that because we're going to add new controls to that. We're also going to change up the field of view and then add some better things. It'll start to feel like a full first-person shooter, except very simple in its frame. So let's get started. So let's go ahead and take a look at the input settings to start with here. So we'll go into the project settings. From the settings view, we go to project settings here, and that takes us to a list of a whole lot of project settings, but we're not going to worry about many of those, probably not for this entire class. But we will look at the input, because that's going to be where we're going to live right now. So this one's a little less overwhelming, if we take a look at that. And in particular, what we're going to pay attention to, and I'm going to go ahead and close some of these so we don't have to worry about it so much, is this set right up here. So we've got our action mapping and we've got our axis mapping. And these correspond to all of the inputs that we allow to come into our game. Right? So this move right and move forward, of course, are very complicated because, as we talked about, we're allowing a wide variety of things like the gamepad, the Vive, and so on. But for us, we're going to really only worry about WS and up and down, right? Same with move right and move left. And then, of course, the turn is based on I guess our mouse X, really, and our lookup is based on our mouse Y. There's also these other versions, but they differ for the types of control. Okay, and again, we'll see that the left mouse button is what we've already been using, the space bar, perform the jump. The difference between these two options are that, well, let's take a look at them. So keep in mind that we have an axis for move forward, move right, and turn, and we have an action for jump and fire. So let's take a look at what that looks like in the first-person controller. So where we see the axes, we see that we get an axis value that tells us a number between, if you recall, -1 and +1. And if we go back and look at, say, the move forward, we see that +1 corresponds to W, moving forward, and then S is -1. And so if we're pressing W, then we're going to get a 1. If we press S, we get a -1. And if we press nothing, then we get a 0. Now what's valuable here is that this also works pretty well with other types of input, like joysticks, where you can actually do a partial input, right? So rather than pushing the stick all the way forward, you can push the stick partway in any direction, and what you get there is a fractional value between 0 and 1, right? So if you push the stick halfway forward, you get a value of 0.5. And same for moving it to the right, you get a value of 0.5 to the left and right, and so on. And so that's what's actually being captured here. That's why you only see a scale of 1 here. We might even say, you could scale it to 2 or something if for whatever reason your joystick was very light and you had to, push it a large amount or something to make it count. But for the most part, you're always going to use a scale of 1 or -1. So again, just for the case of W and S, in terms of moving forward here, we get 1 if W is pressed, 0 if nothing's pressed, and -1 if S is pressed. And then same for A and D, left and right. And for our turn rate here, technically it does correspond to other pieces, except that really we're using the mouse input, and the mouse input is going to control us here, and then that's going to give us the positive and negative. And we can take a look a little bit at that. I recommend you just kind of look at what you're getting here and copy it or modify it as you see fit. Play with the numbers. What's really happening is that we're taking the mouse delta, probably normalized to some degree, but I actually don't know to what degree. And depending on the rate that's happening there, you might either need to change your turn rate that the mouse is using, or you might need to change the scale if it seems like your mouse is a little bit too loose, right? So again, as we look at these things, we do have these other functions. These are internal pawn functions that are changing various things. So we have our yaw, which rotates you left and right. We have our pitch, which is like up and down. Technically, there'd probably also be a roll, but we don't actually roll human characters often. It's usually only airplanes and things like that that end up rolling to the left and right. Human characters get to strafe instead. And then again, we have add movement input forward. And you'll recall that we did look at this. We'll get the forward vector of our camera rather than moving into the world direction. We're going to get forward vector for our camera, the relative direction that we're looking, and that's actually the direction that we're going to move forward. Same with the scale, so we're going to get the right vector and either move positive on the right axis or negative, which is left then. Right? Okay, so because we've named these move forward and move right, we get input axis move forward. Okay, so if I wanted to create a new axis, like if I wanted to create a roll axis, and I'm not going to do this officially here, but we're going to look at this as an example. And say I wanted to use key Q and E as my, let's see, I'll use -1 for Q and positive, let's see where that E key is, there it is, +1 for E. Then because I've created this axis over here, and probably need to save it just to make sure that it's updated, then I can look in here, and when I look for the term input axis, I see that I have a new one called move roll, right? And simply by naming it over here in the input section and giving it some identification, key identifications, key bindings, then we get the whole thing set up for us, right? And then it's going to give us the axis values. And just to show you, there is actually a roll input, right? So we could technically bring this in as well. But again, we really don't want to do that with the first-person controller, unless you're doing something very odd. Okay, so we've got the axis covered, but let's take a look at the other one. So we've got this input action. So input action does not give us a 1 and a 0. Instead, it gives us two different execution lines, right? So when we've pressed the input action, in jump in this case, so it's the space bar if we press jump, then what we see is if we just press the jump, then we'll start a jump animation, right? Or jump situation, whatever that might be. In this case, it's a internal function that causes the character to go up. We also have a stop jumping function, which probably implies that we don't want to double jump, or we want to if we allow extended jumps, we can actually take care of that as part of our character. But in this case, we'll stop jumping as soon as we release the key, right? And for firing, we don't really care about released, right? We only care about when it's pressed. So for firing, we just care every time we press the button, we do it. If, on the other hand, you wanted to manage something like a laser gun or a machine gun or something like that, then probably you would want one set of behaviors that starts the machine gun firing, say, when it's pressed, and then another set of behaviors that stops the machine gun firing when it's released. So again, the two categories there, we've got the action mapping, which is really just a true-false kind of mapping for any of these keys, and then the axis mapping sets the keys to, implies usually a positive and negative along some direction. What we want to do is add two new action mappings. We're not going to worry about new axes. And what we want to do are add a sprint capability and a zoom capability with our camera. So for the sprint, we want to, actually I think I need to go in and remove a key there. So this adds new options to the key, this adds new action mappings. So I'm going to set up a sprint action, and we're going to look at the left shift key here, since this is sort of where we are. And you'll notice that there are these other options here like shift, control, and alt, and those are when you want to do key combos, right? So if for some reason you wanted some long and complicated combo where you had to hit shift and control and then some other key to do something, do some special action, then that's where you would do that. Whereas here, we really would just want to look at the left shift entirely on its own. So if we click this one, we'd still have to come up with some other key here that we want to tie to it. Okay, and then our zoom is going to be tied to our right mouse button. Okay, so again, now that we have those in there, we now have a new, an event essentially that we can work with. So let's go find a reasonably empty spot, maybe next to the jump here. We can set up our sprint case. And what I'll do is I'm going to start with the input action. Oops. I'm going to look for our sprint. You will find sometimes that searching these things, so you'll notice that I did input action without a space in it. I didn't find it, and then when I put the space in it, it found it, but you see there's no space here. So unfortunately, it takes a little bit of practice. It's actually because it's an input here and then the action events, and so it's actually looking there. But just it's going to take some practice to get used to the way you search for these things. We could also search for sprint, right? Especially since that's a very specific name. Same with zoom here. But hopefully, spend some time working with searching and try to get used to it. It certainly, takes a little bit of practice. Okay, so I've got my character movement. I'm just going to pull it over from here. Okay, so if we take a look at the character movement over here, this is where we're pulling from, and what we're changing is this max walk speed that's right here. And this max walk speed is set to 600 as default, and so when we're released, we will change, oops, I don't want to do a get, I want to do a set. We will change it back to 600, right? So let's start there, and then of course the other version is up here. And notice I'm grabbing from the character movement. If I don't do that, and I try to look for max walk speed, you'll notice I can't find it. And that's because it's not a property that's a part of our first person character here. It's really a property that's a part of our character movement. So it doesn't come up through the standard search. If we search for every possible thing, we could potentially be here all day, right? So you have to give some thought before you start searching to what you're searching for, or where on what object you're trying to find it. In this case, we're looking for the character movement, so we're going to say max walk. Now, you might feel a little unconfident in terms of, how would I possibly know the max walk speed is on my character movement? That's part of why we're using the book and part of why we're going through this, right? So now we know that there's a max walk speed there. There's also the point that you can come in here and start exploring yourself, right? So you can also see things like acceleration and crouch speed and things like that that you could potentially also change, right? So don't lose heart necessarily that you didn't know to look for max walk speed there. That's partly why we have the book to help us kind of get a guide through here. But then as we get used to these things and start to try to find them, then we can remember where to find them later on without having to always go reference the book. So these are the cues there. Okay, so this is the setup that the book has to set our speed. So again, when we're pressing the left shift key, we're going to switch to 2200, which is almost 4 times larger, and then we're going to release it and go back to normal, right? Okay, so let's go ahead and put a block around this just to finish it out and say this is our sprint block. That way we can see it very easily when we need to, and we could potentially move it around if we wanted to, but I'm happy with it here. So before we test that out, let's take a look and notice that there's a lot of magic numbers here, right? So we know, as we get used to things, that things like numbers like our max walk speed or crouch will be over here, but we're not going to necessarily know where this 2200 number came from, right? And so if I'm in my map and I'm looking at this and I'm saying, I can come in here and see my character speed. Let's see if I can adjust these windows a little bit. So I can look at my character's movement speed down here and potentially change it. Let's see, and maybe not going to try too hard to find it. There it is. But I don't necessarily know how to change my max walks or the sprint speed that we're doing, right? And so this is a good place to start looking at encapsulation or just the way, the communication patterns that we can take care of, right? So this is maybe a little too encapsulated because it's a hidden number that's kind of magically changing underneath. And if you think about things like speed, walk speeds, bullet damage amounts, max health, and things like that, those are all numbers that have a lot to do with the gameplay and the way the game is going to feel. And so those are numbers that you might actually want to be changing from the map level over here rather than have them internally encoded, right? So if you've got a game designer who's pretty comfortable up front and has said, no, 2200 is the right number, I know it, we're going to keep it that way, then maybe you do want to just leave it as a private value here. But when you're not as sure, when you want to be able to design your game and maybe have some options, then making this a public variable that exists over here that then is exposed at the scene editor level in order to allow you to change it, especially in certain circumstances, change your sprint based on other things happening, then it really makes a lot of sense that that's a variable, and it removes potential for those kinds of unintended consequences down the road when you have multiple things, say setting walk speed directly versus all trying to control a variable or having good communication channels with the variable. So give that some thought as you're designing this on your own and see if you can come up with some good strategies. So now let's test it and see if it's actually going to work. So we'll start by just moving around a little bit. So this is normal movement, and it's pretty reasonable speed. So let's double check. It takes me a few seconds to walk toward that block there. And now I'm going to press shift and move towards it, and we see that I move quite a bit faster, right? There's a little bit of acceleration it takes before I get going, but I can certainly get there quite a bit faster because I'm going to run, right? So that's pretty good. Okay, so that appears to be working well, and again, give some thought to how you might play with that if you felt like that was too fast or too slow. How would you change those numbers other than changing them necessarily here? Okay, so let's fill in our zoom now. So let's, I don't know, make a little room, or I'll probably just work over here. Okay, so our next input action is the zoom, and let's go ahead and just start by taking a look at the first person camera. So we've got our first person camera here. We can see again that there's a field of view. In this case, it's a field of view that we want to play with. We'll get into the rendering later in a different lecture, and kind of where field of view comes in. But a good point of note here is by reducing the field of view, we sort of force the screen to zoom, because we're always going to have the screen fit, say, this whole space here, my full space. But if we reduce the field of view, then we sort of have to make everything still stretch out further. So we're looking at a tinier portion of the screen, and then we make it larger by virtue of just making it fit the screen. So that's kind of the trick we're playing with here. So it's going to end up zooming in just by making the field of view smaller, but it's a cool trick to know that works. And of course the same kind of thing, it works the other way. By increasing the field of view, you zoom out. You can also think of it as looking at a sort of a fisheye lens, right? So if we were to change our field of view to say, I think the highest is, almost 180, not quite 180. Then you could see all of the colors, but then or all of the angle around you. But in this case, because we're looking at such a broad angle, it's going to start looking a little more like a fisheye or widescreen camera, sort of weird effect that you get out of that. Okay, so anyway, we want to set the field of view. So again, it's a property that's on the first person camera, so we're going to take it there. And we want to set the field of view. Oh, that's weird. I did that. And we want to do this, and we're going to set it to 45. We're just going to basically double the size, sort of our input view. So let's see what that looks like when we do that. So again, remember that we've aimed this off to our right mouse button. So I will do that. And of course, there's two problems here. One is, of course, that I sort of instantly jumped in, and I also didn't set the release. So let me go ahead and set the release button. So we do that. And when it's released, we'll set it back to 90. Otherwise, if we set it back to some other number, it's going to look a little weird. Okay. So we set it, we click it, and it pops in, and that's fine. We want to make this a little smoother and easier to work with. Okay, so the book introduces a timeline node as a way of smoothing this transition. And the timeline node here is, again, it's kind of like the delay before. It's a special case node that lets us change numbers over time very easily, rather than having to manage that internally. So we could do this with other features of blueprints by having a variable stored and setting that variable to certain things. But in doing so, we are sort of repeating work. So this is a case where Unreal has actually done kind of the don't repeat yourself mentality and created a nice chunk of a node, something that we might turn into a function ourselves if we were to see it, that we can reuse and create some behavior. So there's quite a few of these, and again, you'll just learn these over time and kind of get used to them. But this is, I guess, a reminder to seek out other lectures will have extra links where people are talking about expertise in Unreal and all that, and those are kind of the special use cases that you learn over time when you get used to an engine, and you just have to get used to, right? It's all part of the process. Okay, so ours, we're going to call it the field of view that I think we're going to change, and then go ahead and edit it. So I double clicked it to bring it in, and I'm going to create a float track, and it's going to be the field of view that I'm changing. And then, let's see, I'm going to want it to start at 90, so I'll just, at time 0, it'll be 90, and then we'll set the length to 0.3, so it'll only take a few seconds to, or a few milliseconds to go. But then at 0.3 over here, we'll add another curve, and this one's going to be, so notice I'm kind of setting the points wherever I feel like. It kind of doesn't matter too much. Oops, time 0.3, and then the value will be 45. But the main purpose here is to get kind of close and then pretty much just edit the points directly. So if you need to, click on a point and then change the numbers. You can drag them around, you can start playing with the actual curve shape itself. But for this purpose, I'm kind of happy with a linear progression from 90 to 45, and that's what we're going to go with. Okay, so we'll go ahead and pop back out. So what happens is, when we're pressed, right, then this node's going to start playing and kind of keep playing, and then during its update, it's going to set the field of view, right? So we only need one because we're also going to use the reverse key. So again, sort of a nice function here, sort of a nice generalizable use case. You can see a really good form of creating useful input channels and reuse, sort of a well-designed room, well-designed node in this case. Thinking back to sort of our discussions of architecture. So in this, we want to, often if we've got a timeline we're moving through space, we might also want to do the inverse of it, right? So in our case, we want to move from 90 to 45, but then when we release it, we want to go the other direction. And so really all this does is just plays the same timeline backwards rather than forwards. Otherwise everything else is identical and all of the nodes come out this way. Okay, so we're firing this thing off. It's going to run through the timeline that we set up, which we've defined here. And again, this curve could be very interesting. If we wanted to be, we could have it sort of loop and move. But I'm happy with linear, and I offer it to you to kind of explore this option, right? As you're learning an engine, as you're learning a game capability, understanding that something exists is one thing, and then understanding what you can do with it is, of course, the real job. Right. Okay. So let's go ahead and block this out and say this is our zoom capability, and then let's see how it looks. Okay. Or see if it works. So I'm going to right click and we see us zoom in for 0.3 seconds and then zoom out, right? So this is much less irritating, I guess, or much less nauseating to have happen to you, especially if you're a background observer and you don't know when that's going to start happening. You get at least a chance to catch up to it, right? There are some animation tricks that we could do, like ease in and ease out, that would make it feel even a little better than this, and I will leave that as an exercise to you to look up and explore. But certainly, this is pretty straightforward to accomplish in that case. So we'll move into maybe a slightly more fun space. We'll play around with a little bit of special effects and sounds, just to start to introduce those, and again, probably primarily because the book is doing so. Certainly worth understanding what's happening, but before we get too far into that, let's open up this first-person projectile. So this is next to our first-person character. It's under the content, first-person blueprints, and the blueprints here. And so, this projectile doesn't exist in the world. So this is kind of an instance where we see, we are creating these things, right? If you recall, if we come down here, we are spawning this as part of the shooting activity that's happening, where it's being spawned off, is where our gun is pointing, and we're just specifying that this is the thing that we want to create, right? So this is another use case for blueprints, in that all the things that we want to kind of spawn dynamically in the world, like bullets, like certain kind of enemies, especially grunt enemies that maybe don't already exist in the world, all these things can be spawned, and this is the node that does it, right? It's actually a spawn node itself, but we'll come back to this, right? So we'll spawn actor from class, and based on the class, it's going to change the name up here. So this is going to spawn this blueprint at the time that it gets fired off with whatever settings are in here. So this is our template pattern that we're copying from. So it starts with an initial speed of 3,000. Let's go ahead and triple that, actually. So the book doubles it. I'm going to triple it because I'd like to be even faster than that, because it's a pretty slow bullet. So this is a pretty easy change, but let's just see that that's happening, right? So every bullet now should get started with a 9,000 speed, right? And so we see it fire off at much higher speeds, which feels a lot more like a bullet, especially when it ricochets, because now it's adding a whole lot of power to the room, right? Maybe a little bit too much power, but that's okay. Okay, so now that we have our bullet set up, let's go ahead and go back to our cylinder blueprint over here. Remember, it's stored over here, or we stored it under assignment 1 content. And what we want to do is we're going to actually set up a sort of a minimal damage thing here, right? So we're going to create a new variable, following along with the book again, at least to start with. And the book creates this primed state, right? And so the primed state is when we set the material to red. And then if we're no longer in the primed state, if we've already been shot once, now we're going to get destroyed, right? So it's kind of, you can almost think of it as, as we talked about, this is a Boolean that's keeping track of 2 hit points, right? The first hit point is going to set as red, and the second hit point is going to destroy us entirely. We could, alternatively, take every bullet and say that's going to give us 1 damage, and it actually takes 10 hits to kill us, right? And so we would set up an integer, and we'd have 10 there, and maybe at the 50% mark, if our integer is less than 5, we'll change the number or change our material to red, and then otherwise, if we hit 0, then we'll destroy ourselves. But let's look at the simplest version, where we're just going to use primed. And so I've described that in English. I challenge you to try that yourself in your own game when you turn this in. But we're going to use primed, and we're going to just use the primed state here. And so we're going to use a branch, as we've discussed previously, but now we're going to actually exploit one to great effect. And rather than going immediately to changing the texture every time we get hit, we are going to change it only here. And then our alternative path now is going to do a whole bunch of interesting things. So to start with, we will, and of course, forgetting the important thing, we also need to set prime to true here, right? So what this code does is the first time through, primed is defaulting to false, right? So let's compile it. So we see that prime is defaulted to unchecked, okay? So we come through and we get hit by our first person projectile, as we've already done, where cylinder turns red. But this time it turns red because we come through and primed is false, right? And so, oops, I'm on the wrong path. So because prime is false, and this is a good reason to walk through this, then when we get over here, it's going to run this code, right? So actually I'm going to move this code, this whole branch down so we can see that. So if we are not primed, then we're going to follow this path, and we're going to set our material, and our material is set to target red, which is a little bit difficult to see, but if I zoom in it looks okay. And now the new thing is we don't not only turn red, but we set our variable to primed. Alright, so let's actually test that out and just to take a look. I'm going to make this a public variable that we can take a look at. No, let's not make it public. Let's come back here and see how we might look at that. So let's go here, and I'm going to shoot that, and now I will pause the game. I'm going to peek at this node. So what we see is that the current value of primed is now true, right? So because I set that, when we first came through here, it set primed, and now primed came through as true, right? So one more time, I'm going to stop playing, I'm going to start playing over here, and in fact this is an alternate way to do that. This actually creates a new window. So when I hover over it, we see that the current value is false. So come over here and, oops, get my aim right. We actually did see the execution go through that line over there. what we'll see is that the execution goes through and stops at the branch if you look closely. You have to look in two places at once. I'll just try to ignore what I'm doing with the shooting. And then we come over here, and so the first time we came in here we saw that it was true, and now we come through and we see that, we saw that it was false, and now we come through and see that it's true. And we don't have anything on our true line, so every time we execute in here, nothing's happening. So let's set that true line up. Okay, so what we're going to do is we're going to play a sound, and we're going to play an effect. Okay, so the first thing is play sound at location. And hopefully you started your project in the right way. If you didn't, you might need to reset at this point in order to bring some of these things in. Okay, so if you've brought in your project in the right way with the extra material available, then you have this explosion sound. So there's a bunch of materials and content, and pretty much whenever you start the game, you should always use the default content because it's great, and we're going to use a lot of it in the examples. So make sure you follow that from the book when you're setting up this project. And then we're also going to, at the same location, I did this kind of quietly because I was talking about something else, but we're actually going to take advantage of this other variable over here. So because we're using an event hit rather than just an actor overlap event, we actually get a bunch of information, right? And we're going to talk about the physics system later and where these kinds of numbers are coming from, or in a different lecture. So these are all coming out of the physics system, which is what we're using here. And so when the bullet hits, it hits at a precise point, right? There's a specific point in space where the sphere is touching the cylinder, and that's the point that we're getting here. There's also a normal, which is the direction of the hit and has to do with how strong the normal and the impulse is how strong the actual hit was. So you can use some of these values to help you figure out like how strong, how powerful you were hit, right? So if you hit with something stronger than say a faster or slower moving bullet, maybe you apply more damage. But all we care about right now is the fact that we're going to hit the location. Okay? And again, we'll come back to the way that Unreal works out these numbers later in a different lecture. Okay, so we're taking advantage of that. We're playing sound at a location, and hopefully if your speaker setup is such that you can do that, you might actually hear it come out of the right or left depending on where it is. It'll also decay the sound a little bit, again by default, and there's ways to play with those values too. Okay, and lastly we are going to add a particle emitter. So we say particle spawn emitter at location, and the particle emitter we're going to do. So it turns out that most of the special effects that you see are particles in games. It's either particles or sprite effects, especially sprites that are rendered onto planes or surfaces as decals and animated that way. But those two kinds of things are kind of the two main ways of doing special effects. For now, we're just going to take advantage of them. So we'll see both the explosion sound at that time, and then we'll play this P explosion. Again, these are from the standard content that you import along with your game when you start it up. Okay, and the last thing we need to do is, this is, as we described, our primed condition. So first time we come through, we set the material red and we set our primed value to true. Next time we come through, primed is true, and we're coming this way, so it's kind of our hit points, or our amount of damage is now 2 total. Or first it was 0, then 1, now it's 2. We come through and now we want to destroy our actor. So we say destroy. And by default the destroy, or the actor that we're destroying, is ourself, which is what we want, because we're the cylinder in this case. And so let's test it out. Okay. So one last time through the mix here, we get our hit. The first time through we're not primed, we go through and set our red material. The next time through, second hit, second bullet, we are primed, we're true, and then we get destroyed. So we both play the sound, we play the explosion at that point in space, and then we destroy the actor. So let's take a look. And we'll get rid of that one, and then we see that it both exploded and got rid of it. All right. And so I only have one cylinder, so I have to start and stop. You are welcome to create more copies of your cylinder. Remember, it is a template, and therefore can be copied multiple times from either copying it from the project, the content browser, or just copying it from the scene. Oops. Okay, so that really covers all of what Chapter 2 covers. I do recommend that you go back, if you have not done so, and read through the details that are covered there. Again, as we noted in this, there are many nodes and features of Unreal which you won't know until you know them. And the best way to get to know them is finding sources of other information, right? Finding the documentation, finding books, looking at the supplemental lectures that I link you to, and supplemental lectures that you can find on your own, and be certain to share those with your classmates as they go, and find those weird and idiosyncratic things that you can do with the engine that may not be apparent.